Try everyone, how can we do this? A spring mass damper system, mass M, stiffness K, damping coefficient C, excited by a force Ft. What is given? Excited by the force F of T is equals to B sine omega t. Correct. Where B omega t are the amplitude, frequency and time respectively, is shown in the figure. Four different responses of the system marked from 1 to 4, right? Shown to the right of the system. In the figure of response, A is the amplitude shown in red color, B is the dashed line. The response represent only the quantitative trends. Those are not drawn to any scale. Drawn to any specific scale. Okay. Four different parameters and forcing conditions are measured are below. That C, you know very well that damping coefficient is greater than 0 and omega is equals to root under K by M. C is less than 0, omega not equal to 0. C is equals to 0, omega is equals to root under K by M. So these are the all values. So what we have to actually find out, which one of the following given options are given are correct match and indicated by arrow of the parameters and forcing conditions to the response. Okay. So guys, you need to tell me what is the right answer for this problem. Everyone please try this. Very beautiful problem it is. Can anyone tell me what is the right answer, guys? So guys, it is a case, you can see it is a case in which it is a problem of forced damped vibration. The problem of forced damped vibration. Forced damped vibration. Okay. So now, my dear, see here. So here what we have PQRS. So there is a sleeping error. There is a PQRS. Okay. So guys, one by one you can see this problem. That's quite easy. Okay. Here everyone, when C is greater than 0, omega is like this. When C is equals to 0, so we can go by the third case. When C is equals to 0, everyone. So when the C is equals to 0, what we can do, my dear? See, we can start because this one is easy. Case R. Okay. When C is equals to 0, the meaning is what? The meaning is your undamped vibrating system. Undamped vibrating system. Undamped vibrating system, right? Undamped vibrating system. Now, my dear, it is undamped vibrating system. So here what we can say, undamped vibrating system we know very well. And here some graphs are there, right? So how can we justify which one is the right answer? So see, that's quite simple. When it is undamped vibrating system, so whenever you solve the equation of undamped vibration, there is no damping in this. So therefore the amplitude, it's not be exponential, right? It will be the straight line, right? Therefore it will be like this, and it is going, this is the amplitude variations. So therefore the right answer for undamped for R is 2, right? Here it will be like a straight line. So therefore R value is 2, my dear. So 2 is here and here. Therefore the correct answer for this problem will be lie between C and D, right? So C and D, from C and D it is the right answer. Now we can see, my dear, again, when we have C, now we need to take, now we need to consider C is greater than 0. When C is greater than 0, everyone, omega is equals to root under K by M. When C is greater than 0, so C is greater than 0, that is the case of what? That is the case of right case case T. When C is greater than 0, so I have already discussed the damped vibration, damped force vibration, damped vibrating system. And once you solve this equation, you are going to get what? First case. And the first case is the answer. Okay, that is the graph for damped vibrating system. So therefore, the right answer is 1 and 2. Means for P, the right answer is 1. So for P, the right answer is 1. Therefore, the correct answer for this will be C. C is the right answer, everyone. Okay, please. Okay, great. I hope this part is done. And now either if you don't remember the graph, then you have to solve it by solving the equations. So by solving the equations is very lengthy, right? So once you prefer through the basics equations, you will get this will be a straight line and this will be your for parabolic, right? So that is very, very important. Remember these results, that is important. Okay. Next part, guys, see. Next part, what we can do here. See, this one is, this is also a problem from the epicyclic gear train. So maybe you guys are aware with the epicyclic gear train problem. Okay. So can anyone please try epicyclic gear train? How can we solve? We have done so many problems based on this. Can anyone solve, please? Epicyclic gear train, everyone. Please solve this. How to solve? Anyone? Quite simple. So we know very well that the schematic diagram is given to us. The a schematic of epicyclic train is shown in the figure. The sun and the planet gear are external. The sun gear and the planet gear are external, and the ring gear 3 is internal. Ring gear 3 is internal. The gear 1, gear 3 and arm are pivoted at the ground. The gear 2 is carried on the arm OP via the pivoted joint P and is in mesh with the other two gears. Gear 2 has 20 teeth, gear 3 has 80 teeth. If gear 1 is fixed, what is written here? That is very important line. Gear 1 is fixed. Okay, at 0 RPM, and gear 3 rotates at 900 RPM counterclockwise. The magnitude of angular velocity of OP. Okay, means arm. So that's quite simple. We know very well what we are going to do. We have these results. Arm, gear 1, gear 2, gear 3. Okay. So now, see, everyone, what we can do, the speed of the gear first will be 0. Suppose its speed is your x. So gear 1 having teeth, number of teeth we need to write. Gear 1 having teeth. Where is the number of teeth in gear 1? Number of teeth in gear 1 is not mentioned in the problem. Right. A schematic diagram of exactly gear train is shown. Sun gear 1. Sun gear 1, right? And gear 2 are external. Ring 3 is internal. Gear 2 has 20 teeth. Gear 2 has 20 teeth. 20 teeth. Gear 3 has 80 teeth. Right? Okay. If the gear 1 is kept at 0 RPM and gear 3 rotates at 900 RPM. Okay, no problem. Gear 1 is fixed, which means okay, my dear. So how can we find out? Because without number of teeth, how can we find out here? I think there is something missing in this problem. Number of teeth is required, right? Right. Number of teeth we need to find out. So how can we find out? See, we can do one thing, everyone. See, because gear 1 number of teeth is not given, so we can use that radius R1 plus 2 R1 plus R2. See, this is the R1, this is the 2R2. Is equals to R3, right? So what we can write, MT1 by 2 module MT2 by 2 plus M is equals to MT3 by 2, right? Cancel, my dear. Here 2 is there. Okay, so here T1 plus 2T2 is equals to T3. Okay, so now what we can say, T1 teeth, how we can get T3 minus 2T2. T3 is your 80. 80 minus 2T2 means 2 into 20 means 40. So that was the catch in this problem, that 40 is the number of teeth in T1, right? Now you know very well that how can you write this one. So this will be your C. You know very well that N1 by N2 is equals to T2 by T1, right? So here what we can say, N2 by N1 is equals to T1 by T2, means N1 T1 by T2, right? If we got N2, N1 T1 means 40 into X, 40 into X by T2, correct? So since 1 and 2 are externally meshing, that minus sign will be there. Now 2 and 3 are internally meshing. This is your minus 2x. So now minus 2x into 20 minus 2x into 20 by 80, right? This is your minus x by 2. Suppose I am giving a speed, it's x plus y, your y minus 2x. This is your y minus x by 2. Correct, everyone? So now read the question clearly, what is given here. If the gear 1 is fixed, gear 1 is fixed. So when gear 1 is fixed means x plus y is 0. If gear 1 fixed means x plus y is equals to 0. Therefore, x is equals to minus y, correct? Now x is equals to minus y. In question, read this question. Now gear 3 rotates at 900 rpm counterclockwise. Gear 3 rotate at 900 rpm. Means you can write y minus x by 2. 900 rpm counterclockwise, my dear, means minus 900. Like because it is counterclockwise. So here y instead of y, what we can write minus x by 2 minus 900 minus 3x by 2 is equals to 900. X is equals to 600, right? 600 rpm, okay. X is equals to, my dear, 600 rpm that we are getting, okay. Now, what is asked in the problem that the magnitude of angular velocity of OP. OP means arm speed means we have to find out y. So y is nothing but y is your minus x, means y is equals to minus 600 rpm, means y is equals to 600 counterclockwise. The right answer for this problem is 600 counterclockwise. So here what is asked? The magnitude. Magnitude means 600 only. Therefore, the right answer for this sum is your 600. Clear, everyone? Note down, guys. I've already discussed this. How can you solve? Note down, everyone. Now see, everyone, the next problem. So I have discussed the equation with you, my dear. In balancing, what is written? A rigid body in xy plane consists of 2 point masses attached at the end of the two massless rod, each of 1 centimeter length, as shown in the figure. It rotates at 30 rpm in clockwise about the axis. Point mass of root 2 kg is attached to one end of a third of a third massless rod. Is used for balancing the body by attaching the free end of the rod at point. The length of the rod, that means the radius, is actually asked in this problem. So you know very well, everyone, how to find out that. I have told you that you can use this equation. Okay, since the angle is 90 degree, right? So I have discussed you for balancing, everyone. Remember that balanced mass is required here in this. So therefore, how to write MBRB, you know very well. MBRB in balancing, that quite simple. Equation is there. MBRB is root under, right? Since it is 90 degree, you can write M1 R1 square plus M2 R2 square, right? Therefore, we can do here M1, this is your mass, balanced mass is root 2 kg. So root 2 into RB, radius of the balanced mass. M1 is your 1 kg, radius is your 1 into 1 square plus 1 into 1 square. Therefore, root 2 RB is equals to root 2 RB cancel. Therefore, RB is equals to 1 centimeter. Correct. RB is equals to 1 centimeter. Do everyone do this. So that is quite simple problem. RB is 1 centimeter. The right answer is 1. Very easy problem. It was very, very easy. Okay, guys. Great. Done. Next problem, guys, we can see. See, for a dynamic system governed by x double dot plus zeta omega n, right? X dot plus omega is n square, right? X. So here the damping ratio zeta is equals to 1 by 2 pi log 2. 1 by 2 pi log 2. No problem. The displacement x of system is measured with the hammer test. Displacement peak in the positive displacement is measured to be 4 mm, right? Displacement is measured to be peak is measured to be 4 mm. Okay. Uh, Neglecting the powers of the damping ratio, the displacement at the next peak in the positive direction will be. Okay, the displacement of the next peak in the positive direction will be. So guys, see, actually whenever you see its graph, it will be like this. Whenever you see its graph, it is going like this, right? And this will be your exponential. This will be your exponentially, it is decreasing, right? Remember that. Exponentially decreasing. Okay, so this is your x1, suppose. This is your x1. This is your x2. The first amplitude is your x1. The first amplitude is your x1. This is your x2. Okay, so x1 amplitude is given to us. X1 is your what? 4 mm, right? And actually x2 we need to find out. That is quite simple. Logarithmic decrement ratio is given to us. So we know very well, my dear, delta, logarithmic decrement, that is called delta. Delta is your 2 pi zeta root under 1 minus zeta square. Correct, my dear? So here we can find it out. And delta is the ratio of ln x1 by x2. Correct, my dear? So zeta is given to us. Zeta is what? See, zeta is your this ratio. So please solve this, everyone. 1 by 2 pi ln2. What we are getting, ln2 divided by this is your this we are getting, everyone, 0.110. 0.110 means 0.110 upon root under 1 minus 0.110 square ln x1 by x2. Ln x1 by x2, x1 is your 4 by x2. Right. So once we solve, we are going to get the answer. This value is what? Right. This we are going to get 0.697 ln 4 by x2 is your e to the power here is your 2 is equals to 4 by x2. Therefore, x2 is equals to 4 by 2. This your 2, whatever data, mm, centimeter, mm. Therefore, the right answer is your 2 mm. 2 mm is the right answer. Quite simple problem it is, my dear. Right. 2 mm is the right answer. So note down, the right answer is your 2. Correct. Clear? Srivastav Prathamesh is, sir, 1 by 2 pi log 2. 1 by 2 pi log 2. 0.048. What is this? 1 by 2 pi log 2? 1 by 2, 1 by 2 pi. C. 1 by 2 pi. This we are getting this one. 0.110. You can please calculate. You please calculate 1 by 2 pi log 2 base C. Log 2 base C. Okay. Now the next problem. Just balance the force in this ball. We'll get the answer. That's quite easy. See everyone, what we can say. The figure shows here the two balls. The balls P and S of equal mass. See, this is a ball P, this is a ball S. Right. The vertical distance between the horizontal plane rotation of the ball OA, and this is the H. The H value is 400. If the omega is double, then H will be. If the omega is double, then H will be what, my dear? So guys, see what we can do here in this, everyone. Suppose I just want to draw the free body diagram of this ball about this. So the ball, you can write the ball having one mg here in this, the ball having one mg in this direction. Okay. And this is your mr omega square. Mr omega square. Okay. Mr omega square. Now guys, tell me, mr omega square. So here, this is a centrifugal force. So if suppose you are going to take the moment about this hinge. So therefore, this distance will be your r. Mg into r, there will be one torque in the clockwise direction. Mgr is equal to the one torque for this force, right? So therefore, this height is your h. So this is your mr omega square into h. So what we can write, m cancel, r cancel. H is equals to g by omega square. Means h is inversely proportional to omega square. Clear? H is inversely proportional to omega square. So that is quite simple. Means h omega square is equals to constant. Means you can write h1 omega 1 square is equals to h2 omega 2 square. H1 is your 400, omega 1 is given to you. Double means omega is omega. H2, this is your 2 omega square. So 400 into omega square is equals to H2 into 4 into omega square. This is cancelled. This is your 100, means H2 is equals to 100 mm. The right answer is D. Right, so that's quite simple question. Everyone note down. Quite simple question, my dear. Clear? Great. Okay, great. That was the easy problem, everyone. So the questions which has been asked from this topic is over. Thank you for joining me. We have solved all the questions of theory of machine and vibration. Thanks a lot, everyone. Bye, all of you. Thank you.